Introducing K Model web application for predicting crude oil compatibility and optimization. K Model application can be run using any web browser. To get started, open any web browser and type the address. Once you enter the address, you will land on the login page. Type the username, that is, your registered email ID and the corresponding password. Once you log in, you will land on the product landing page. The product has 3 modules. The first module is for the crude oil blend compatibility and it has 2 sub-modules. The Model 1A is for the prediction of crude blend compatibility for known blend compositions. Module 1B is for predicting the most optimum and compatible crude oil blend that can be achieved using a set of crude oils. Similarly, Module 2 is for bitumen potential identification of blends. Like Module 1, here also you have 2 sub-modules wherein by using the Module 2A, you can check whether for a given crude oil blend composition, bitumen potential is present or not. And the other sub-module, that is Module 2B. You can estimate optimum blend composition of crude oils with bitumen potential. The third module is for fuel oil blending, which gives you a tool to optimize the cutter stock and minimize the cost of production for a fuel oil of certain desired specifications. The first application, Module 1A-T, is for crude oil blending compatibility without any optimization. If you press this 1A button here, you will land up in the application page for Module 1A. This is the front page of this application, which allows you to check the compatibility of blends whose compositions are known to you. In a single run, compatibility of 20 crude blends can be estimated with a maximum of 10 crude oil each. The first input that you need to provide is the number of crude oil for blending. Depending upon the number of crude oil to be blended, numbers of rows in this input form will change. If you want to check the blend for, let's say, 5 crude oils, you will have 5 rows present here to give the inputs. You can also choose the unit of temperature, that is, degree Celsius or degree Fahrenheit. Also, there is an option to choose the unit for defining the blend composition. You can define it in weight percentage or volume percentage, and the price of the product can be defined in dollar per barrel, or it can also be chosen as rupees per ton. You can also change the title of this test, since you will be using modules for testing different cases, so you might require to change the title for each of these cases. Let's say for this case, the title is Test 1. You can rename the test name and that would come as the part of report. Next, you need to give the inputs. You have to type the crude oil name here like this, or you can also choose to use the Excel-based tool to fetch this data from a pre-filled Excel form. The download button here allows you to download the Excel-based input sheet. This Excel tool assists in feeding the input data to the web application. As you can see here, there are 2 tabs. One is for crude oil properties and the other is for crude oil composition. This is exactly a replica of what you're required to fill in the web application. In the first tab, you need to enter the properties of all the crude oil for which compatibility is being checked. The details required are crude oil name, their source and properties like the MCR, API, sulfur kV, pour point, and finally the cost. In the second tab, the crude oil blend compositions are to be defined. The software will predict the compatibility of these defined compositions. The Excel sheet also allows you to choose the units of temperature, Fahrenheit or Celsius, or you can also choose to use dollars per barrel or rupees per ton for crude oil cost. Once you fill in these data, you can actually use it to import the data into the web page. For this demonstration, a pre-filled sheet is available. Once it is uploaded, all the required data needed for the application will be imported to the web page. Once the data is uploaded, you can verify whether everything has been correctly uploaded. The next input is the description section, where you can add any description you want to add as a remark for this run. The application is now ready for the run, and next press the run button. Once you press the run button, it will ask for the confirmation because each of these runs is being accounted in your account. The application will ask for this confirm button to be pressed, and once you confirm, the application will carry out the calculations and give you the results. In this run, 5 check cases were given and all these compositions were analyzed and their compatibility was estimated. For all the input compositions, blend properties, distillate yield and the compatibility results are reported. You have the option to download this report in PDF format and also in Excel format. Once you click on this, the report will be downloaded as a PDF format. This is the PDF format report. The report starts with the list of tables, figures and unit summary. It will also give you the details that have been used as input for this run. The properties that were used for the crude oil blends are also given here. Then you have the input compositions that were used for the run. These are the 5 compositions that were tested as shown in the web application. The corresponding pie charts also reported, and finally the results. For blend number 1, which actually asked for 50, 30 and 20 volume percentages of these 3 crude oil, the blend properties are listed here and the blend compatibility results are also given along with that. Similarly, for the remaining blends, the results are also collated in the PDF report. At times you're required to import the result in Excel sheet because you might choose to use this data somewhere else, in any other software. We have also provided the option to export the results in Excel format so that you can link it for further use in applications downstream. Here also you're going to get all these input properties that we have as input for the run, and then the output tab provides you the compatibility results. So you have these output properties and corresponding distillate yield, and then finally compatibility results. All the output that is available in the web page are also there in the PDF format as report and Excel format for further usage in any other software. Now the second module, Module 1B, is for crude blend optimization, where you're not going to give the compositions of the crude oil, but you're going to ask the software to tell which composition is the best, or rather most economical in terms of blending, so that your productivity and profitability is maximized. Here also you will see similar kind of interface wherein the properties of all the crude oil have to be given. You can use the same upload and download Excel buttons, which actually helps you in fetching the data. Once you input this data, you will have all these input parameters uploaded into the application. Along with that, you can also define few blending constraints. You can actually insert up to 8 blending constraints. So, these are the blending constraints: acidity, the API, the kinematic viscosity, MCR, pour point, sulfur, total nitrogen, total distillate yields. Along with the blending constraints, you have the option to add capacity constraints. Here in this case, 3 capacity constraints are defined. Next, you can maximize or minimize a particular crude oil. This is the objective function basically for the optimization program to run. In this case, Ratawi being the cheapest, it was chosen for maximization. Once you're satisfied with the input data, hit the Run button. The application will ask for this confirmation, and once you hit it, you will have the report. These are the results as per the calculation. 81% Ratavi, 17% Murban and Upper Zakum of 2% is the most optimum blend in terms of price. These are the corresponding characteristics of these blends, and then of course all these results are compatible. It won't show you results which are incompatible. The application gives the 20 top compatible blend compositions and their characteristics, and also the cost of those blends. So it will give 20 best blends starting from the cheapest one, that is the 42.52, and then this 20th one will have the higher price, which is somewhere in the range of 42.94. Like in Module 1A, here also you can download this result as PDF and Excel sheet for further usage. The next module is for the bitumen potential, where you can predict the bitumen potential of a given blend. This model also has two sub-modules. Module 2A is without optimization, wherein the user has to define the input compositions for which bitumen potential is being estimated. Module 2B is with optimization, wherein you're only giving the prospective crude oil details and the software itself predicts where is the most optimal blend for getting high bitumen potential. Let's start with Module 2A. Here also you have to give the inputs for all these crude oil that you want to check. The Excel input for can be used for the same. It will pick all these three crude oil that we have been testing, and instead of compatibility, now we have these four compositions and you want to know whether bitumen potential is available or not. Once the input sheet is ready, hit the Run button. Once you do that, we have the report here. Like in Module 1A, here also you will get the characteristics of these blends for these defined compositions and whether there is potential for producing bitumen or not. For all the three blends, we can see that there's a potential and the corresponding cost. The fourth blend, it says intermediate, which means the decision is much more closer and we need to check closely whether the potential is present or not. The report can also be downloaded in the similar manner as the first module, and you can download as PDF and Excel format. The next module is Module 2B, which is with optimization, where you're not really giving the composition details, but you're asking the software to calculate the most optimum composition with bitumen potential. The same three crude oil data that have been used till now will be used as input. Once you do that, all these input parameters of these crude oils will be imported to the software, and then you choose rupees per ton or dollars per barrel based on your requirement. Then you can choose the blending constraints, whether the sulfur, pour point or any other parameter, you can add that, and it can be taken in like, let's say total distillate yield should be greater than or equal to, let's say 75. Next, you can give the capacity constraints. So for 3 crude oil, we can give 3 capacity constraints. Next, you can opt to maximize or minimize any of these crudes. Once you give all these input data, you can press the Run button. The application will give the results. The most optimum blend and the cheapest would be Ratawi 84, Murban 15 and Upper Zakum 1. So it will be cheapest and also will have great potential for bitumen. As you go down, you will see the price of these blends would increase and 20 potential blends would be tabulated based on the price in the report. Like in the previous case, here also you can download the report as PDF and Excel format. The last module is the fuel oil blending module. It's same as module 2B or 1B. The only difference is it is for fuel oil blends. Basically, the most economical and compatible fuel oil blend can be arrived at. You can go up to 5 vacuum residues and 5 cutter stock for blending. The application will come up with the most economical blend of vacuum residue and cutter stock. You can upload the input data through the Excel sheet input form. Once you do that, the input data will be imported to the application. Once satisfied with the input, user can hit the Run button. Result shows that there are no optimal solutions available. This means there are no optimal blends for the chosen input. This may be because the given constraints are not satisfied. There are few other functionalities such as Profile, where you have user details, the password details and the subscription details. It tells you how much usage you have done, which application you can use more. It also gives you the history of the runs you have done till date, so that you can fetch those results on a later date. This concludes the demonstration of this K Model web application.